Students, now let's see independence of attributes. Independence of attributes. Two attributes A and B are said to be independent if there is no relationship of any kind between them. Now, if A and B are independent, we would expect the same proportion of A's amongst B's as well as betas. Now, here, for example, if intelligence and sex we are taking, then these are different things and these are independent. The proportion of intelligent people among males and females would be what? Same, but not of other. Fine. So the definition: two attributes A and B are said to be independent if there is no relationship of any kind between them. If A and B are independent, we would expect the same proportion of A's amongst B's as well as betas. Similarly, the proportion of B's is same amongst A's as well as alphas. Fine. For example, if intelligence and sex are independent, the proportion of intelligent people amongst males and females would be same. Now there is one criteria for independence, so let's see that one. We will check that criteria. If it will satisfy, we will say they are independent, otherwise they are not. Criteria for independence: if A and B are independent, if A and B are independent, then frequency of AB upon A is same as frequency of alpha B upon frequency of alpha. Then by the property of proportions, we get frequency of AB upon A equal to alpha B upon alpha plus AB plus alpha B upon A plus alpha equal to B upon N. That is same as frequency of AB equal to frequency of A into frequency of B upon what? N. So we can say another definition here, that attributes attributes A and B are said to be independent. If frequency of AB equal to frequency of A into frequency of B upon N, or frequency of AB upon frequency of A is same as frequency of alpha B upon frequency of alpha. Moreover, as frequency of AB upon frequency of A is same as frequency of alpha B upon frequency of alpha, so frequency of A minus frequency of AB upon frequency of A and frequency of alpha minus frequency of alpha B upon frequency of alpha, all these are what? Equivalent. Therefore, frequency of AB upon frequency of A equal to frequency of alpha B upon frequency of alpha, that gives A and B are independent. They are independent. Fine. Similarly, we can say frequency of A upon frequency of B equal to frequency of A beta upon frequency of beta. Therefore, B minus frequency of AB, frequency of B minus frequency of AB upon frequency of B, that is equal to frequency of beta minus frequency of A beta upon frequency of beta. Therefore, AB minus AB is what? Alpha B upon what? B. And here we get this is alpha beta upon what? Beta. So what does this say? This gives alpha and B are independent. Alpha and B are what? Independent. Hence we can conclude that if the attributes A and B are independent, then first alpha and B are independent. Alpha and B are independent. Here A and second A and beta are independent. A and beta are independent, and the third thing, alpha and beta are independent. Alpha and beta are independent. Let's see one example to check whether the A and B are independent or not for given data. So, example, determine whether the attributes A and B are independent given that frequency of AB is equal to 256, frequency of alpha B equal to 768, frequency of A beta equal to 48, and frequency of alpha beta equal to 144. Let's see the solution. Frequency of A is what? Frequency of AB plus frequency of A beta, that is 256 plus 48, that is equal to 304. Again, frequency of B is equal to frequency of AB plus frequency of alpha B, that is equal to 256 plus 768, it is 1024. Now what is N? N is equal to frequency of AB plus frequency of alpha B plus frequency of A beta plus frequency of alpha beta all together. So 256 plus 768 plus 48 plus 144. So it is 1216. Now frequency of AB is how much? 256. We will check, is this one equal to frequency of A into frequency of B upon N or not? Fine. So this is equivalent to what? Frequency of A is 304 into frequency of B is 1024, sorry, this is 1216. So if we take this division, that is also 256. So these are equivalent, hence the attributes A and B are independent. Attributes A and B are independent. Fine. Now the next topic is of association of attributes. Association of attributes. Two attributes A and B are said to be associated if they are not independent but are related in some way or the other. They are said to be positively associated or associated if the frequency of AB is greater than frequency of A into frequency of B upon what? N, and negatively associated or dissociated if frequency of AB is less than frequency of A into frequency of B upon what? N. In other words, two attributes A and B are positively associated if frequency of AB upon B is greater than frequency of A beta upon beta. Therefore, frequency of AB into beta minus frequency of A beta into B is what? Greater than 0. This is another criteria for that, for positively associated. So, from this, what can we write? Let me simplify it further. Now, therefore, AB into, what is the value of beta? Beta is what? A beta plus alpha beta. Again, minus, this is A beta as it is. Now, let us substitute B. What is B? It is AB plus alpha B. And that is also positive. Now, let's open the brackets. It is AB into what? A beta plus AB into alpha beta minus A beta into AB minus A beta into alpha B. That is also positive. Fine. Therefore, delta equal to what? AB into alpha beta minus A beta into alpha B. That is positive. This is known as, this will we say as delta. These two terms are get cancelled here. Only two terms are left. Fine. Now, this is delta. Similarly, if this delta is less than 0, we can say the two attributes A and B are negatively associated or dissociated. Now, Let's see one note here. Note. First, attributes A and B are said to be completely associated if frequency of AB is same as frequency of A or frequency of AB is same as frequency of B. If frequency of AB equal to frequency of A, we get frequency of A beta will become 0 and frequency of AB is same as frequency of B gives that from this we get frequency of alpha B is what? 0. Also the second note we can say attributes A and B are said to be completely here associated, completely now dissociated, if frequency of AB is 0 or frequency of alpha beta is 0. It is completely associated if frequency of A beta 0 and frequency of alpha B 0, and completely dissociated if frequency of AB 0 or frequency of alpha beta 0. Fine. Now here we will stop. In next video we will see Euler's coefficient of association and examples on them. That will be our last topic of this chapter. Thank you.